Hello everyone, and welcome back to If It's Math. Today we're going to finish our series on exponents as part of our Fundamentals of Algebra content. In the first two videos in the exponent series, we talked about positive and negative exponents and how you work with those, as well as the rules that you follow when using exponents. So in this video, we're going to put all that to use as we practice simplifying expressions that involve exponents, where you have to use several of the rules of exponents in the same problem. So by the end of this video, you'll be able to use all of the different exponent rules at the same time to get a complicated expression to be something simpler and easier to use. So let's go ahead and get started with a quick recap. I'm just going to go through the exponent rules really quickly. If you need additional refresher, please go back and watch the second video in this series, which did go through all these in detail. But I'm just going to summarize them real quick as a refresher. So the first is the zero exponent rule. So the zero exponent rule just tells you that anything raised to the zero power equals 1. It's really simple. Technically, it's only if x does not equal 0, but you always pretend like it's not 0 just to be able to move forward. So anything raised to the 0 power is 1. So the next is the product rule. So the product rule tells us that x to the m times x to the n equals x to the m plus n. Now, one of the important things here is you have to have the same base. So the only way you can add these together is if it was x in both instances. So let's look at a quick example of this. If you had x to the third times x to the fourth, that is going to equal x to the seventh, because you just add them in together. Okay, so then there were three power rules, remember? The first is if you raise an exponent to an exponent. So if you have x to the m, all that raised to the nth. So it's not the same thing as the product rule because you have powers raised to powers. So what that's going to give you is x to the m times n. So as an example here, if you had x to the third to the fifth, that's going to be x to the 15th power. Okay, power rule number 2. That told us if we're raising two things multiplied by each other, it'd be helpful if I get it right. So two things multiplied by each other raised to an exponent, that's the same thing as each of those individually raised to the exponent, then multiplied together. So xy to the n is x to the n, y to the n. So if we think about an example here, if you had 2x raised to the fourth, the whole thing, that's going to give you 2 to the fourth, x to the fourth. Simplify that out, you get 16 x to the fourth. So then the third power rule talks about fractions. So if you have x over y to the n, that is x to the n over y to the n. So again, if we think about an example, if you had 2 over x to the third power, that's going to give you 2 to the third over x to the third, which is just 8 over x to the third. Believe it or not, that is a 3 over x to the third. There we go. So then next we have the quotient rule. And the quotient rule tells us that if you have x to the m divided by x to the n, that is going to equal x to the m minus n. So looking at an example there, if you have, let's say, x to the third divided by x to the fifth, then that is going to give you x to the negative second. So then the last rule I want to take a look at is fractions to negative powers. So what this is looking at is what if you have, say, x over y to the negative n. So what that told you is that you can flip it and then raise it to the positive exponent. So that is the same thing as y over x to the positive n. So think about an example for this one. If you had, say, 3 over y raised to the negative third, that is the same thing as y over 3 to the third, which is y to the third over 3 to the third. which is just y to the third over 27. Okay, so that's all those rules. As a refresher, again, that's because we're going to be using all of them as we keep going through these examples. So let's talk about how we actually do this. So if you think about how we're going to simplify expressions with exponents, there are really two goals. So this is not as procedural as some other things in math. You kind of have to look at it and assess, okay, what's going to be the best way to do this? But they're kind of these goals that you're going to be looking at. So the first is you want to get rid of as many exponents as possible, and you have to get rid of all negative exponents. There can't be any negative exponents left. And that might sound a little confusing because, well, what if you have them in there? Remember, a negative exponent just means you can turn it around and put it on the other side of the fraction. And then the other thing you're going to want to do is get rid of as many parentheses as possible. Sometimes you might have a few left, but you're always going to get rid of as many as you can. And then in general, the process you follow is that you want to work from the inside out. So if you have some gigantic expression, we'll look at a couple in a minute, and you have all this and all this in here, and then all that's raised to an exponent, you don't want to distribute the exponent through first. You want to get the inside as simple as you can before you start doing anything else on the outside. So again, two goals. Get rid of as many exponents as you can, including every negative exponent. Get rid of all the parentheses if you can, and if not, leave as few as possible, and then work from the inside out as you're doing that, because that's going to make life a lot easier. So really the best way to see this is to walk through it. And what I'll try to do is talk a little bit about my thought process as it goes, so you can see why I take certain directions. There's no particular order you have to follow, other than, of course, you have to do the everything inside parentheses before you move out. But you could distribute things through before you simplify on the inside, but I'll just talk you through why I do things the way that I do as I go. So let's take a look at the example x to the third, y to the seventh, over x to the negative second, y to the negative third. So we're going to start simple and then get much more complicated as we go. So if we follow our rules for this one, we know that we can do x to the third minus negative 2 times y to the seventh minus negative 3. So remember, that all comes back to this rule where when you're dividing exponents, you subtract. So you get x to the 3 minus a negative 2, and then y to the 7 minus a negative 3. So that's where all that came from. So that started out with that rule. So now we just need to really simplify this. So that's going to give you x to the 3 minus negative 2, which is x to the 3 plus 2, which is 5. And then y to the 7 minus negative 3 is 7 plus 3, 10. And that's it. That's your answer. So x to the third, y to the seventh over x to the negative second, y to the negative third becomes x to the fifth, y to the 10th. So let's take a look at another one. Start getting a little more complicated. Let's say we had x to the negative second, y to the sixth, over x to the fourth, y to the negative third, and we're going to raise all of that to the second power. So this is where you start to have some choices, right? Because technically, you can take this exponent and distribute it through everything in here and everything in here. But I really advise against that, because you're going to have to be doing this to everything in here when some of this is going to simplify out. So you're going to make, again, life a lot easier for yourself if you simplify what's inside and then raise it to the exponent, because you'll be doing less work in the long run. So let's go ahead and take a few of these first steps. So let's do what we did before. We're going to look at getting these exponents together. So we'll have x to the negative 2 minus 4, y to the 6 minus negative 3. And then we got to remember, we still have all that squared. So let's simplify this down. X to the minus 2 minus 4. We're going to end up with x to the negative 6th. And then y to the 6 minus negative 3 is 6 plus 3. So 9th. divided, or not divided by, raised to the second power, all that. Okay, so now we're going to go ahead and use that next rule. So the next rule, remember, if you have exponents raised to exponents, you multiply. So this is going to give us x to the negative 12, y to the 18th. Okay, you might think that you're done, but you're not, because remember, one of those rules was that you can't have any negative exponents in the final answer. So this is where you have to remember that a negative exponent means 1 over whatever it's representing. So what that really just means is you can move whatever has that negative exponent applied to it to the bottom of a fraction. So this is going to become y to the 18th over x to the 12th. And that is your final answer. So we don't have any parentheses left anymore, and we don't have any negative exponents left anymore. Okay, let's take it up one more level. Add one more complicator to the whole thing. And let's say you have x to the third, y to the sixth, x to the negative fifth over y squared, x to the negative fourth, y to the negative eighth. And it's still not done. So let's raise all that to a negative exponent this time. Okay, so the first thing that I see when I look at this is I have some of these like terms in the tops and bottoms. So I really want to get that simplified before I even think about doing anything with that negative third power out there. So let's start with getting each of these simplified. So let's simplify this numerator and then simplify this denominator. So right here you can see I have x to the third, and remember the order you multiply things in doesn't matter. So I've got x to the third times x to the negative fifth. So I'm going to go ahead and take that and simplify it out a bit. So that's going to give me x to the third minus 5, because remember you're adding them together, and then y to the sixth over, let's do the same thing with the y. So we had the 2 and the minus 8. And then I've still got the x to the negative fourth. Don't forget, we still got to raise all this to the negative third power at some point, but not right now. Okay, so the next step you can see is we just need to simplify this down. So we're going to have x to the 3 minus 5, so that's going to give us x to the negative second power, y to the sixth over y to the negative sixth, x to the negative fourth, all to the negative third power. So all I did in this step was just simplify out these exponents. And now what I see when I look at this is I've got x's in the bottom and top, and I've got y's in the bottom and top. So I want to get that simplified down because I know I can collapse that sum. So what's going to get me there is I will have x to the negative 2 minus negative 4. Because remember, in this case, we have these divided, so you subtract it off. That'll be multiplied times y to the sixth minus negative 6. But I've still got to do all this to the negative third power. So again, all we did here was use that rule that when you're dividing exponents, you subtract out. Okay, so let's simplify this down. It's going to start coming together. So x to the negative 2 minus negative 4 is x to the negative 2 plus 4, which is just going to give you x squared. Then y to the sixth minus negative 6 is y to the sixth plus 6. So y to the 12th. Raise all that to the negative third power. So next we can finally take care of this exponent. Remember, if you have exponents raised to exponents, you multiply. So you'll have x to the 2 times negative 3, which is negative 6, and y to the 12 times negative 3, which is negative 36. And again, avoid the temptation to say that you're done, because we still have negative exponents. We got to get those negative exponents out. And remember, the key to that is that anything raised to a negative exponent is like you need to flip it over to the other side of the fraction. And so you don't have a fraction here, so it's kind of understood to be over 1, so you're going to flip it all over. So this is going to give you 1 over x to the 6th, y to the 36th. And that is going to be your final answer. We don't have any negative exponents. We don't have any parentheses anymore, so we are good to go. Okay. So we're going to do 3 more. So now let's take it up one more level. All the examples that we've been looking at so far just had variables. We didn't have any numbers in there. So let's throw a number in and see what happens. So if we have 2x squared y to the 3rd over 3xy squared, I'm going to do all that raised to the negative 2nd power. Okay, so again, just to walk you through the way I think about this, of course I've got this exponent looming out here, but I really want to simplify this as much as possible before I apply all that. And when I look at it, I see things I can simplify, right? I've got x's in the numerator denominator. I've got y's in the numerator denominator. So let's take care of those and see what happens. So what I'm going to end up with here is getting those x's and y's taken care of. So I'll have 2x to the 2 minus 1, y to the 3 minus 2 over 3, still raised to the negative 2nd power. All I did here was look at these, right? I have a 2 and a 1, 2 minus 1, a 3 and a 2, 3 minus 2, and then I've still got that 3 hanging out down here. So now let's simplify that down. So the top will just have 2 times x, y. Because 2 minus 1 is 1, 3 minus 2 is 1. I've still got my 3. We're still raising that to the negative 2nd power. So the next rule we're going to need to use here is I want to distribute this exponent through, but it's a negative exponent. So remember, what happens when you have a negative exponent is that you flip the numerator and denominator and then make this a positive exponent. So this is going to become 3 over 2xy raised to the positive 2nd power. So from there now, I can distribute through this exponent. So I'm going to have 3 to the 2nd power, and then 2 to the 2nd power, x to the 2nd power, y to the 2nd power. So this is going to give me 3 to the 2nd power, which is 9, divided by 4x squared, y squared. Just remember, when you distribute an exponent through a fraction, you multiply, same thing, everything by that exponent. You raise everything up to that exponent. And so this is our final answer. A really bold box, right? So that gives you 9 over 4x squared y squared as your final answer. Okay, we're going to ratchet up 2 more levels still. So let's look at our next to last problem. And let's introduce exponents raised to exponents with some numbers in there as well. So let's say we have 4x squared to the 3rd power times 2y squared to the 4th power all over 3x to the negative 2nd power squared times y to the 4th to the 3rd. Okay, so I didn't put an exponent big on the outside. So let's think through what we're going to need to do here. So, you always want to work from the inside out with your parentheses. I don't really have anything that can be simplified here on this, right? So 4x squared, nothing really to change. 2y squared, nothing to change. Same thing, same thing. So I need to start applying these exponents to what's inside. But you need to, again, pay very close attention to what it's actually touching. So what this is going to become, let's start with that 4x squared to the 3rd power. So this is going to become 4 to the 3rd power and then x to the 6th, because you multiply that 2 times 3. So that's what that's going to turn into. Then I've got this 2y squared to the 4th, so I'll have 2 to the 4th, and then y squared to the 4th, which is going to give you 2 times 4 to give you 8. hopefully an 8 that you can read, right? The 8th, there we go. And then same thing we're going to go through in the bottom. So I'll have this 3 squared x to the minus 4, because I have negative 2 times 2. That's going to be multiplied by my y to the 4th to the 3rd. Multiply that y to the 12th. Okay, so now I want to take care of these numbers, because I have 4 to the 3rd, 2 to the 4th, 3 squared. So I can go ahead and turn those into the numbers that they represent. So 4 to the 3rd is going to give me 64. So I have 64x to the 6th times 16 y to the 8th over 9 x to the negative 4 times y to the 12th. Again, all I did there was just do my numbers. Okay, so now let's go through the top and bottom and simplify each one. So I've got 64 times 16, x to the 6th, y to the 8th. So what that's going to give me is 1024, x to the 6th, y to the 8th, divided by 9, x to the negative 4th, y to the 12th. So a few things that we see left, right? So 1024 is not divisible by 3, so it's not divisible by 9 either, so I can't reduce that at all. But I'm still in the situation of having the same variables in the top and bottom. So I know that I can simplify that down more. So let's go ahead and do that. We will end up with 1024 x to the 6th minus negative 4 y to the 8th. Y'all, I got a problem with the 8s, right? Let's make it better. Y to the 8 minus 12. Divide that by 9. Okay, so now let's go ahead and do that math out. So I'll have 1024 x to the 10th, y to the negative 4th, all divided by 9. And again, it looks like you're there, but you're not. You still got this negative exponent, so we got to take care of that. So remember, all you do with a negative exponent is take whatever it applies to and move it to the other part of the fraction. So we're going to end up with 1024 x to the 10th divided by 9y to the 4th. And that is your final answer. Okay, so just one more level, I promise. Only had 2 variables so far, so let's throw in a third variable and see what that does to us. So let's say that we have 3x squared, y to the 3rd, z to the 6th, all of that to the negative 2nd power, divided by 2y squared, z squared, to the negative 3rd. Sorry, not done. Let's do the whole thing raised to the negative 2nd power. Okay, if you can get through this one, you've got it down. So let's go ahead and walk through it. So now hopefully you can start to see what I'm talking about when I say you want to get this as simple as possible before you start doing these things. Because if I did it right now, I'd be applying this to the negative 2nd power to this, and then all that to that, and it's just way too much. So we're going to start from the inside, work our way out. So the first step is going to be, let's get this negative 2nd kind of distributed through all of this. And then at the same time, we'll get this negative third distributed through all of this. We're going to leave all this stuff alone. Okay, so let's get that to the negative second power through everything in the top. So that's going to give us 3 to the negative second, then x to the negative fourth, because I have 2 times negative 2, y to the negative sixth, because I have 3 times negative 2, and then z to the negative 12th, because I have 6 times negative 2. So that's all going to be over 2 to the negative third, y to the negative sixth, because it's 2 times negative 3, and then same thing with the z to the negative sixth. Then don't forget, still got all this raised to the negative second power. So all I did with this step is just take this negative second power, distribute it through all these things, take this negative third power, and distribute it through all these things. Okay, so we've got these numbers raised to negative powers. So let's go ahead and take care of those. Remember, we're going to move this to the bottom and this to the top because we've got those negative exponents. So that's the only stuff I'm going to take right now just to get that out. So you're going to be able to flip those over, right? So now we have 2 to the positive third power. Nothing else has changed. X to the negative fourth, y to the negative sixth, z to the negative 12, divided by, now I've got this one coming down. So now I have 3 squared, y to the negative sixth, z to the negative sixth. So all I did was just move those out. Still got my whole thing raised to the negative second power. So now I'm going to start looking at where I have like terms. So x to the negative fourth, I don't have any x's in the bottom, but I've got these y's and I've got these z's. And then while we're at it, let's go ahead and take care of these numbers. So what we're going to get out of this now, 2 to the third power is 8. Still have my x to the negative 4 because I didn't have anything in the denominator for it. But now I've got my y to the negative 6th minus negative 6, and then z to the negative 12 minus negative 6. All I've got left in the bottom now is just that 9. I've still got to raise this all to the negative second power. So again, all we did here was look at this y to the negative 6 divided by y to the negative 6, and this z to the negative 12th divided by z to the negative 6th. Okay, so let's simplify this down one more step. So what this is going to give us is 8x to the negative 4th, y to the negative 6 plus 6 is 0. Then z to the negative 6th, of negative 12 plus 6. I've still got all that divided by 9, and all that raised to the negative second power. Getting close, I promise. So when I look at this, before I go to this step, I've got some negative exponents, so I really want to get those down there. So I'm going to get down to 8. Now remember here, y to the 0 is just 1. So that goes away, because 8 times 1 is just going to give me the 8, divided by 9 times x to the 4th, z to the 6th, all that raised to the negative second. Getting very, very close. A couple more steps. So now we've got this negative exponent on the outside of a fraction. Remember, with this negative, what you can do is flip around the fraction. So now I'm going to have 9x to the 4th, z to the 6th over 8. And now I've got this as a positive fraction. So to get this to a positive fraction, you just flip over the fraction. So 8, 8, 9x to the 4th z to the 6th, 9x to the 4th z to the 6th. So now last step. We're going to need to take this squared, square everything in the top, square everything in the bottom. So this will give me 81. 9 squared is 81. X to the 8th, because I'll do 4 times 2. Z to the 12th for 6 times 2, divided by 8 squared, which is 64. And there you go. You did it. So all that big thing at the top came down to 81, x to the 8th, z to the 12th divided by 64. Okay, I know that was a whole lot. Feel free to go back, take a look at these again, watch each step to understand why you do things in a certain order, why things aren't fully simplified if you still have negative exponents. So just as a quick summary, what you've been doing is you're going to eliminate as many exponents as possible, make sure you have no negative exponents, and get rid of as many parentheses as you can. And then as we did that, we worked from the inside out because that made life easier. And that's it. That's all there is to simplifying expressions with exponents. I hope this video was helpful. Please like it if it was. Subscribe to our channel to be the first to know about our new content. And always remember that if it's math, we have the solution.